Exponential decay is a situation where our b, now we're calling it a decay factor, is between 0 and 1. This means that the value of whatever our output is goes down every year. For example, there are 300 axolotl in the ocean. Each year, 80% of the previous year's axolotl survive. I still have a start value, like usual, 300. But now to get the next year's axolotl, I multiply my previous year value by 80% as a decimal. That means my decay factor is 80%, moving it 2 decimals to the right, 8/10. So if 80% survive, I'm repeatedly multiplying the 300 by 8/10, times 0.8 times 0.8 times 0.8, so that 80% of the previous year gives me the current year's axolotl. If 80% survive, that means 20% die. That means my percent decrease is 20%. It's actually really uncommon for me to give you what percent survive. Usually I tell you the percent decrease, so I would say 20% die, and then you'd have to calculate the decay factor. The way you do that is you do 100 minus the percent decrease, and then again write that percent as a decimal. So in this situation, if I would have said the number of axolotl decreases by 20% a year, I would have done 100 minus 20, telling me that 80% survive, and my decay factor is 0.8 to represent 80%. Here's a similar situation. Instead of telling you what percent survive, I'm telling you what percent die. Man, this is a little rough. That means my decay factor is 100 minus 100% minus whatever percent die. So 15% of the original amount, that 100% die. That means I have 85% remaining, making my decay factor 85 hundredths or 0.85. My function rule will always be written with a decay factor representing how many are still alive or how many remain. So if I tell you how many remain, that goes straight into my decay factor. If I tell you how many die or decrease, then I have to use that to calculate how much remains. So my function rule is f of x equals start value of 300 times 85% repeatedly. If I were to multiply instead of by 85% or 0.85 by 0.15, I think you can see that that would be a really drastic decrease, much bigger than I'm looking for. If I multiplied it by 15%, that would mean that 85% actually died. So 15% decrease corresponds to an 85% survival rate. So for each of these, we want to see, am I being given the percent decrease, or am I being given what percent remains? Here we have an oil spill, starting with 500. And each day skimmers filter out 32%. I'm taking out 32%, so it's not that 32% remains. To find what percent remains, I have to do 100 minus 32, which is 68. That means 68% of the oil each month remains. So 500 times 68% to the x, that means 68% remains, 32% is filtered out. Here, again, a car is worth $5,000. Its value decreases by 7%. So I do not find my function rule by using directly that 7%. That would mean that I had a really, really low value after the first year if I multiplied by 7%. Instead, I have my original value minus 7%. 2 decimal places to the left. My decay factor is 0.93 or 93 hundredths. That means I take the original value, 5,000, and repeatedly multiply it by 93% or 0.93. 93% of the value remains. 77% goes away. Finally, we have one where we have some caffeine and 84% remains. That means I can just write 84% as a decimal. 84% remains. I start with 400. 84% remains. 16% goes away. Finding the half-life is a calculator question since I don't know how to solve this algebraically. The half-life means when do I have half of my starting value? So to find this, I would plug the function rule 400 times 0.84 to the x into the y equals in my calculator. I would go to my table and I would look to see when the half-life is about 200 milligrams, or when the amount of caffeine is 200 milligrams. That will be my half-life. It's my x value.